Hey everyone, in this video I'm going to show you how you can graph 3D parametric equations in Desmos. The motivation for this is that it's a lot easier to transform graphs with parametric equations than it is with your normal Cartesian equations. And so in this video, I'm going to introduce you to them, and in the following video, I'm going to show you how you can translate them and also rotate them. Now, I'm going to show you some examples. So the way you would do this, there are two ways I know of that you can graph parametric equations. There's one they can do similar to how you do it in 2D, which is use a t variable. And so if we had an equation, like let's make up some equations. T goes in the x component. Let's make a 2t in the y component, and let's make the z component x t squared. And so you can see that we have a bit of a problem going on in 3D space. The other way you can go about it, and this is the method I'm going to be using throughout the video, and that is using a UV pairing. And so three variables that Desmos understands on parametric equations is t, u, and v, but the pairing that it understands is u and v. Let me show you what I mean by that. If we were to graph a cylinder, you might do something like, let's do cosine of t, sine of t, and a z that looks like this. But if I swap this out for either a u or a v, you will notice that the calculator tells you that it thinks that t and u are both variables, and it doesn't understand what to do with it. But if you swap this out for cosine of u, sine of u, and you put v in here, it understands it. So I want to put that out there for those of you trying to graph with this format. And that also takes me to the two ways that you can plot a cylinder. So if you want one where the sides are solid, this would be the method to go. The U here is for the circular cross sections, and so that one we want to span between minus 2 pi and pi. Because I'm 2 pi, excuse me, because in radians this is your minus 360 degrees, and this spans to your 360 degrees, and the v here is your height. And so if you want it to span from z equals 0 to z equals 1, this would be where you would do it. The other method, actually, before I show you the other method, for those of you wondering on how do you orient the cylinder differently, like say you want it to be facing z and y, you would want to draw the circle this way, right? With the two axes you're interested facing you. And so in this case, if y is your new horizontal axis, you would make the y where your cosine is, and the z where your sine is. And since now your x is your depth, that's where you put your v in. So now if we look at it the way we originally intended to, you can see that now we have the circle facing us. The other method I'm going to show you is what if you just wanted to use t? I've seen cylinders represented this way. So in this case, I'm going to go with the vertical orientation. And so that would be cosine of t, sine of t, t here. And so for this t, I'm going to give it a large number. Okay, 10's not very large. Let's go minus 10. And I'm doing this realizing that my graph is upside down. If you don't like how this is spiraling like so much like that, you can squash this. What this means is now, like, if you want this to, if I squash this by 10, but you want to get those 10 units back, I believe you need to scale this up by what you divide it by. So I've scaled this down by 10, and therefore I need to multiply by 10. So that's an example for a cylinder, and it'd be appropriate for us to put this in a folder. The other example that I think you may be interested in is how do you do a cone? Because I know a lot of you watch my videos for the conic sections tutorials. So for a cone, let's do the vertical orientation. That would be our cosine of u, not cosine of u, it's u times a v times the cosine of u, v times the sine of u, plus the depth. And so for the u, same thing, we want it to span from 2 pi to positive 2 pi. And the v, again, is our depth, right? So now we're starting from 0 and want to end. That looks like 3 up there, but if you don't like that your tip is ending at 3 and you want something larger, scroll your mouse wheel back and you'll get more. So this is the same feature that you would find on the 2D version. And I'm going to do same example, the cone, which is what if you want to only use t, so that would get you one continuous line drawing a spiral, but it would shape the cone. And let's orient it. Last time we did y and z, so let's do x and z. What would that look like? We still have t cosine of t, because nothing about that has changed, but our new vertical axis is z. So that would be t in the y-axis, since that's the depth, and for z, that would be t cosine of t, t sine of t. Hide this so you can see this better. I'm also going to squash this by 10. I'm going to use the same range. The t that we should be squashing is the one that represents our depth. So let's do that. That looks very ugly. Actually, in this case, if you went forwards and backwards, your cone would actually get you the two cones pointing at each other. So we go back to this example. If you want the negative side, it'll show you both cones. So this looks like the cone that you find in your algebra textbooks, and you can stick a piece of paper here, stick a plane in here, and you can get your conic section shapes if you so choose. That's one use case you might have. Or if you want to draw a better sand clock that I did in my 2D video, feel free to go this way. Now, this graph, in case you're wondering, will be available in the description. So this ID pointing to this graph, well, is in the description if you want to go check it out for yourself. And next video, we're going to be transforming this graph. So how do we move this on the X, Y, and Z axes, and how do we rotate it out them? Hope you found this video helpful. If you did, consider leaving a like. If you didn't, let me know in the comments what you would have found helpful. Thanks again for watching. I'll see you next video.